In this video here, we'll look at solving trigonometric equations, but using general solutions. In this particular example, we'll look at cos of x equals to 1/2. And the difference between general solutions and other solving trigonometric equations is that usually you will be given a domain. But in this case, for general solutions, you aren't given a domain, which means that we need to find all possible solutions for this equation. The first step here is to take cos from the left-hand side to the right-hand side by applying the inverse. Then we will take the unit circle to investigate what cos inverse of 1/2 means. Essentially, we are looking at when the x value is equal to 1/2 in the unit circle. And the position here is when the x value is 1/2. And the coordinates on the unit circle that give that is this point here and a point in the fourth quadrant here. The corresponding reference angle to these two solutions is pi on 3. And this first solution here will be pi on 3, and this second solution here, if we consider a domain from 0 to 2 pi, is 5 pi on 3. So we have pi on 3 and 5 pi on 3, but they can go on forever. The question is, how do we get all of the solutions to come out? In this case here, we will need to use the idea of the period. And the period for a sine or cos graph is 2 pi. So when we go to write out our general solution now, or general solutions, we will have two equations. We'll have one general solution for pi on 3, and we will also have one general solution for 5 pi on 3. And in order for us to get back to this pi on 3 here, a repeated number of revolutions, we need to add on 2 pi. So that's what we're going to do. We're going to add on 2 pi, but we're going to repeat that any amount of time. So we can either go forward by adding, or we can go backwards. So we're going to introduce an integer or a whole number, which is n. Now n can be any whole number. It could be any negative whole number. It can be 0, or it can be any positive whole number. And we'll investigate what that looks like soon. Same with 5 pi on 3. If we want to get to the same position as 5 pi on 3, but go in the positive direction, we will add on 2 pi. And if we want to go into the negative direction, we add on negative 2 pi, or subtract 2 pi. So this n here is an integer. Now when we introduce the n, we need to define what it is. We say that it is an element of z. Z here is referring to an integer, which is a positive or negative whole number, or 0. Now, just to make this look a bit cleaner, I'm going to go ahead and simplify this so that when we substitute numbers into n, it will come out a lot easier and we don't have to do too much mental calculations, or too many mental calculations to get there. 2 pi is the same as 6 pi on 3. So 6 pi on 3 times n, or 5 pi on 3 plus 6 pi on 3 n. What I'm going to do is I'm going to merge these because we all have the same denominator now. We can say pi plus 6n pi all over 3, or x is equal to 5 pi plus 6n pi all over 3. Now these are our two general solutions where n is an element of Z. I might just write that in all of the lines for consistency. How do we get our solutions now? Now let's say, for example, if they want us to produce the first three positive solutions, you can start by letting n equals 0, then n equals 1, then n equals 2, so on and so forth. Let's investigate what happens when we let n is equal to -1. This will give us x equals 2. When n is equal to -1, we have pi. 6 times -1 is -6 pi. So pi minus 6 pi is -5 pi on 3. Or, if we substitute in -1 here, we've got 5 pi minus 6 pi, which is -pi on 3. So that's our solution set if n is equal to -1. If we let n equals 0, this whole term here, we go 6 times 0, that whole term there turns into 0. We're left over with pi on 3. So pi on 3 is our first solution for that pair. And for our second solution here, if we multiply n with 0, that whole term there turns into a 0. We're left with 5 pi on 3, which is our first two base solutions there, as you can see. If we let n equals to 1, we get the next solution pair up if we go around the unit circle. So if we let n equals 1, this becomes 6 pi. So we've got pi plus 6 pi, that becomes 7 pi on 3. And last but not least, if we substitute it into this second solution of the pair, we will get 5 pi plus 6 pi, which is 11 pi on 3. If the question is asking us to produce our first three positive solutions, we can see here, these are our first three positive solutions. We've got three pairs of solutions here. 1 pair, 2 pair, 3 pairs. Now, if there is no domain, this would be our answer. But if they ask us to produce any amount of solutions, we can substitute in values of n to produce our solutions.